it's not too bad. And that's the plastic one. It's not too bad. Okay, so the process I used to make the tool path from the picture was as follows. I started off by getting a picture and processing it through GIMP. This, by the way, is the way I did it, and there are many other ways of doing it. So I opened up my profile picture from YouTube, and I selected the bit in the middle here, and what I did then was I cut out the head in a different file, and I made it monochrome by using the filter in GIMP, where you can go to filters or colors, desaturate, and desaturate gives you the means of choosing the way of removing the color. So I did that, and I processed it a little bit and came up with something which I thought looked a bit amusing and from a newspaper or something. And then I give it a background because I wanted it to be routed to a rectangle, and then I applied a median blur. You see this? We go to filters, blur. There are many sorts of blurs, but a median blur works quite well. Why didn't that do anything? Because I'm not on the right picture. Try that again. Filters, blur, median blur. And what you do is you set the amount of blur. The radius here determines how much. There's no blur, 1, 2, 3 pixels. You can have a lot more. So 3 pixels looked reasonable to me. And the reason that we apply a blur is that when it is this sharp, it would be a very jagged tool path up and down, as the white pixels are high and the black pixels are low on the contour, and so when it's got a noisy picture, it would be a very noisy tool path, and I wanted a smooth tool path, so I thought I'd apply blur to make it a much smoother outcome, a bit like visual sandpaper. So once I'd done that, I loaded the image into a web page called Image to STL. Now there are many other ways of doing this, but I happen to upload it to this site here, and all that you do is you upload a file. I dragged and dropped it onto the page, which I shall do now by finding the file, and it's on this screen to my left. You can't see it at the moment, and I find it and I drop it onto the web page, and there's the file, and you tell it on this box here how deep you want the cutout to be, the routing to be, and I'm setting it to 3 millimeters deep, and I tell it to make an STL file, and that's what the STL file would look like. I tell it to download it, and then I save it onto my disk. It's a zip file, so I then have to extract that zip file, and then I load it into Kirimoto. And in Kirimoto, you would go to Files, Import, and then select the appropriate file, which would be in one of the directories that I've downloaded stuff into. We're not going to do that because it's already here on the workbed. Now in Kirimoto, you have to set up a few things. So you have to tell it what sort of tools you've got on your CNC machine. And I've done that for the ones that I have available to me. And for the routing of this, I've used a 4.5mm ball end tool, which I got off eBay. and I chose from the operations which are available down here, I chose to do a roughing pass and then a single contour pass in the X direction. I could have added another contour pass, for example. And it would default to being in the Y direction because it knows that. You probably wouldn't want two X direction passes by default. And here its feed rate is 1000 millimeters per minute, and then it's stepping over by 1/3 of the tool diameter with each pass of the routing. And there are various other parameters, each of which has a tool tip comes up against it to explain what it does. Okay, I'm not going to actually select that one. You can also go around and select the outline of the workpiece, and that will route all the way around the outside to cut it out from the workpiece. I'm actually going to disable that in my run, and also I'm going to make sure that the origin is set to the center. That sets it to the X. That sets X and Y coordinates to the center of the face of the workpiece, or my face in this case. And the origin top sets the origin Z equals 0 to be the surface of the material. So when you start the job on your CNC machine, you touch the tool down to the surface and check that it's resting on the top of the material when you begin, and then it cuts down from there, as opposed to having Z equals 0 being the bed or something like that. Because if you did that, then it would be very important that you have your material exactly the same as you'd simulated in your simulation here. So once you have set up your roughing pass and your contour pass, you would like to know what the toolpath would look like. So you actually press the slice button, and that shows you toolpaths it's generated. You can look at a preview which shows you the actual movements of the tool. Let me take those off if you want. Take off the arrows which are on there. Take off the moves. And that's the milling taken off as well. And finally, actually not finally, and next you can do an animation. And it's good to do the animation because it tells you what you can expect to see when you actually run it on the actual instrument. So this is the roughing pass where it's removing the bulk of the material. For convenience for me, I leave it to do the roughing pass with the same tool as it does the contour pass. You can speed this up a little bit. It doesn't even have a slow down button, so it will go a bit quickly once I do speed it up. You can see the process there. And there we go. It has produced the toolpath and simulated it, and we can see what we would roughly expect. For example, you could choose to go back to the previous screen and change the step over to being a much smaller amount to get a much finer finish with less visible lines if you chose to, but that's entirely fine for what I wanted. And then you would of course want to export the toolpath and give it a name which is suitable for what you want. You would tell it to download it, you would save it somewhere. This is running inside a browser, by the way, inside Edge in my case. It did not work properly in Firefox, so I'm using Edge for this particular program. and you would save it somewhere, for example in one of your folders that you're working with, and it will download it as a G-code file directly, or it will zip it if you're expecting a very large file, for example. I'm not going to actually, yes, I will download this one. Let's download it again just for the hell of it. Contour routing stuff, and we're going to give it a new folder of demo. Stuff it in there, say save, close, and then in this program what you can do is you can save your workspace, and that's the equivalent of saving your project with all of these settings and your tools and everything else. Everything is saved in one big file. And it will make a zip file, and you can then download it to a folder somewhere, for example that folder. And I've saved the project here, so when you're working on multiple different things, as this is a web-based program, this is the way that you save and load your projects. So now there's the next stage that we have to do, which is the file which has been created. This is the previous file. Actually, this one will do. It's not exactly the same as the one I've just made, but it's very close. It's got in it a tool selection command. In this case, it says M6, which is the tool change command, T3 for tool number 3, which is my 4.5mm diameter ball end cutter. And Gerbl, GRBL, does not understand that command, so I have to comment it out. If there are multiple tool change commands in your code because you've changed tool, or for different processes, for example roughing and contouring we're using different tools, then you will have to do a search and replace to comment out all of the tool changes. Okay, so I would then save that. Once that was saved, I would then open UGS to run the program on my CNC machine. Okay, so I stopped it before the Y run on the Y contour pass, because I think I'm going to leave it like that because it looks like a raster scan with the horizontal lines on the old television screens. So we'll see how this comes out on the next run. L0 set Z0 in the software. We're at X0, Y0, Z0, which is the centre of the workpiece. I've already checked it's fine, won't run off the end or crash into anything over here. Let's move the cutter up. .340, 20,400 RPM, and then I press play and the fun begins. I've dropped that to 19,200 RPM. Okay, that run was at 320 on the variable frequency drive, which corresponds to 19,200 RPM. And there we go. It's not too bad. That's the plastic one. It's not too bad. It's good when the light's directly above it, you see, because you get the shadow below the nose, because it looks really weird. The actual thing's got a big hole underneath the nose, but that's to cast a shadow when the light's above it. Yeah. It's not a bad technique. Seems to work. What a frightening face. So, the other way that you can turn a picture into an STL file is using our old favourite program, Cura. If we bring in that picture that was on the desktop just before, Dingo 0 Square, then what you want to do is, in my case, is I want the lighter parts to be higher on the generated STL file, and I want the height of the item to be, 2.5 is good, but I could set that to 3 or 10 for example, but we'll stick with 2.5. That's good. Here it's telling you that it will make a slab on the bottom of the thing which is 0.4 millimeters thick. That's fine, I don't mind about that. And you say OK, and brings it in. And there you go. There is your STL. And you'll see it says that highlighted areas indicate either missing or extraneous surfaces. Fix your model or open it again into Cura. So that's done it. I did take that into Curimoto and it did produce a toolpath. I am not too sure about the quality of the file compared to the other one. It may be better, it may not be as good for routing, I don't know, but it certainly very quickly produces what appears to be a perfectly usable STL file. So that is the other way that I found of generating an STL from an image file with software that you may have already have installed on your machine. Have fun.